Okay, we're going to look at starting a chapter on radians and use of radians, but we'll start off by doing a recap of what we looked at in Year 12. So to convert from degrees to radians, your fraction is times by pi over 180. Basically, your number in radians is much, much smaller than degrees, so it's common sense, it's small over big. Whereas to go the other way, from radians to degrees, times by 180 over pi. If we're looking at standard angles in degrees, 30, 45, 60 and so on, as fractions of pi, well pi is 180, so 30 is a sixth of it, so I'd write it as pi over 6. 45 is a quarter of it, pi over 4. 60 is a third of it, pi over 3, and 90 is a half of it, pi over 2. And all the other ones are just multiples of these. So 120 is 2 lots of 60, so it's 2 pi over 3. 135 is 3 lots of 45, so it's 3 pi over 4. And 150 is 5 lots of 30, 5 pi over 6. To go beyond 180, we've got top heavy fractions, so 240 is 4 lots of 60, 4 pi over 3. 270 is 3 lots of 90, 3 pi over 2. And 315 is 7 lots of 45, obviously, 7 pi over 4. And then 360 is 2 pi. If I'm changing from degrees to radians, therefore, as we said above, I need to make the value smaller numerically, so times by pi over 180. So let's have a look at 39.24 times by pi divided by 180 equals 0.684. Two decimal places, 0.68. Minus 280.49 in exactly the same way, times by, try again, shift in that case, pi divided by 180, check my pressing buttons, minus 4.895 minus 4.90 to two decimal places. Nice and straightforward. To go the other way, to go from radians to degrees, times by 180 over pi. And if it's in terms of pi already, I should get a nicest answer. The pi's obviously cancel down. 180 over 12 is 15, so 11 times 15 is 165 degrees. Nice and straightforward. If it's a decimal, 1.637 times by 180 divided by pi equals 93.79, 93.8 degrees. If I'm solving equations, I need to consider my range. Do the obvious things. 2 sine theta equals 1, sine theta equals a half, which means that theta in degrees will be 30 degrees, which is pi over 6, or 180 minus it, or pi minus that, 5 pi over 6. Remember, almost everything's got the second answer in the 0 to 2 pi range. Example here, a bit more to do. Sine 3 theta divided by root 3 equals cos 3 theta. Because my range has changed, I need to extend the range of possible answers for 3 theta instead of 0 to 2 pi from 0 to 6 pi, times everything by 3. Because I'm going to get potentially 3 times as many answers. So a quick switcheroo of these two gives me tan 3 theta, which is sine over cos, which is root 3. So 3 theta is the inverse tan of root 3, which is 60 degrees, pi over 3. Second answer in the 0 to 2 pi range, add 180 on, or add pi on, 4 pi over 3. But because I've extended my range, I'm going to have 3 times as many answers. So I don't just get 2, I'm going to get 6 of them. So I can go, add another pi on, 7 pi over 3. 10 pi over 3, running out of space, 13 pi over 3, and squeeze it on, 16 pi over 3. And divide everything by 3 to get theta now. Pi over 9, one answer. 4 pi over 9, fine. 7 pi over 9. 10 pi over 9. 13 pi over 9, and squeeze it all in perfectly, 16 pi over 9, and that's still in that 0 to 2 pi range. Okay, so because of the different range for theta, it's 3 theta instead, It's squished it by a factor of 3, so I get 3 times as many solutions. Another example, 4c. Cos squared theta minus pi over 9 equals 1. Just in case, I'm going to change my range by taking pi over 9 off to 18, 17 pi over 9. Cos squared, don't forget, when I've got cos squared, I'm going to square root it. So cos of theta minus pi over 9 equals plus or minus 1. And in this case, I've got to think quite carefully as to what I'm going to have as my solutions for theta minus pi over 9. I'm going to get 0. I'm not going to get 2 pi, because 2 pi is out of my range. So I don't get 2 pi, but I am going to get pi. And then theta, therefore, will equal pi over 9, 10 pi over 9. Just checking that and making sure with my reasoning there, that seems to be okay, because the 2 pi would give me an answer outside of my range, so that's fine. Okay, lastly, a quadratic equation. I've got a mixture of sine squared and cos. Because I've got cos on its own there and sine squared, what I want to do is change the sine squared to 1 minus cos squared. And because I'm feeling lazy, I'm going to write c for cos. I'll come back to it later on. Minus c minus 5 equals 0. 6 minus 6, c squared minus c minus 5 is nothing. Move everything across to make the cos squared positive. 6c squared plus c plus 5 minus 6 minus 1 equals 0. Don't know, I'm going to be factorising here, maybe. 2c and 1, 3c and 1, let's have a think there to get, I've got plus and minus equals 0 to give me the plus 3c minus 2c is that one. So cos x is minus a half, or cos x equals plus a third. And it says there, give an answer in terms of pi where appropriate. So cos of minus a half, I can, in case I'm not sure, make sure my calculator in radians, shift cos minus 0.5 equals 2 pi over 3 and 2 pi minus that, 4 pi over 3. So I've got an obtuse angle and a reflex angle. And cos x is a third. It'll give me shift cos 1 divided by 3 equals 1.23 and 2 pi minus my answer 5.05. So I've got my 4 solutions, 2 of them in terms of pi and 2 of them not. For part B, just once, hence solve the same equation, well, almost. It says it's got 2x in and x is between 0 and pi. So it's where 2x is between 0 and 2 pi. So 2x equals 2 pi over 3, 4 pi over 3, 1.23, 0, and I'll just check there, 5.05, 2, so when I halve it, x equals pi over 3, 2 pi over 3, 0.615, 0.62, and 2 point, you know what, my brain's gone, there we go, 2.53. Just in case. A new calculator will come into their own eventually, and there we go.